All right, so we're now going to learn a little something new, something that's sort of interesting. So to start with, I'm going to have you just draw something in your notes. So you should have your notes a blank spot out. And I'm just going to do sort of a rough diagram. I want you to draw an angle that looks like about 30 degrees. So start by just putting a sort of a dashed line down at the bottom, and then a dashed line coming up at about 30 degrees. Doesn't have to be perfect. You don't need to use a protractor or anything. And we'll call that angle A, and that has to stay 30 degrees. Okay. Now side A, of course, is going to be across from there. Side B is going to be over here. We're going to call that length 5. And so to do 5, we're just, again, we're not going to get a ruler out or anything, but just approximate it. Try and take your thumb and put 1, 2, 3, 4, 5 thumbs out there. So mine's maybe out here. And then you can sort of solidify that. Okay. So that's about 5 of my thumb widths, right? So 1, 2, 3, 4, 5. And so here's the final piece of the puzzle. So everybody should have the same thing right now. And so I'm now going to have you draw side A. And so side A has to be over across from angle A, of course, and I want that to be 3. And so that should be about 3 thumb lengths. And so just pause the video here for a minute and draw in what you think that third side length would look like. And then once you're done, compare answers with a neighbor and see if they drew the same thing as you. So go ahead and pause the video now. Okay, welcome back. I'm guessing most of you probably did something like this and said, okay, 1, 2, 3, and get something like that, right? And that's a very reasonable answer. This side's definitely a bit shorter than this one. It comes down and hits the dashed line. And so I now have side, and an angle that's not between them, right? So I have 2 sides, but the angle I know is not between them. And so this is called the side-side angle case. And it's going to turn out that this is also called the ambiguous case. And so if you don't know what the word ambiguous means, it can mean a variety of things, I suppose, in different contexts, but basically means it's something that's not clear, right? If you say something that's ambiguous, someone's not really sure what you exactly mean. So before we come back and talk about why this is ambiguous mathematically, let's look at a couple ambiguous statements that don't have to do with math. So think for just a second about why each of these are ambiguous. And if you want to pause the video, you can. I'll leave it up to you. So I don't like flying planes. So why is this confusing? What does this person mean? Maybe have a quick discussion with the neighbor. Why does this have more than one meaning? And of course, maybe there's even more than 2 meanings, but one meaning would be, I don't like the physical act of flying planes, like I don't like being a pilot. Or the other would be, you just don't like planes flying over your house. You don't like planes that are flying. You're not doing the flying. So a little bit ambiguous. What kind of flying don't you like? Grandmother of 8 makes hole in 1. That was a newspaper headline apparently somewhere. Of course, hopefully this is talking about golf and not some sort of stapler accident, something like that. The lady hit the man with the umbrella. What is ambiguous about that? Of course, the main question is who has the umbrella, the lady who's doing the hitting or the man who is getting hit? Who has the umbrella? I saw her duck. Of course, does she have a pet duck, or did she duck because someone was trying to hit her with an umbrella? He gave her cat food. So he gave her food for her cat, or he actually gave the cat some food. So these are ambiguous statements. Back to the math problem. Why is this triangle situation ambiguous? And maybe someone in the class has something that looks a little different than this. It's possible. Most people probably drew this one, I'm guessing. But it turns out you could have also had your thumbs come back this way. And when I come back this way, I can get another triangle in here. This one also looks like it's A equals 3. And I still have B equal 5, and I still have angle A being 30 degrees. And so this is ambiguous, right? Which is the correct triangle? Is it the one we started with that's out here, right? Or is it the one sort of on the left here with this big obtuse angle here. And we really have no way of knowing. And so if this problem comes up, I would have to give both answers. There are two different possibilities for angle B, and we'll find out how to find those in just a second. But first, get your notes out or get another blank spot in your notes, and we're going to try to make sure we know when we get two angles or two triangles. And once we know when there are two triangles, then we'll figure out how to actually solve them. And so we're dealing with this situation, right? So it's an SSA case, right? And so that means we know two sides and an angle that's not between them. And so we're going to sort of break this into two cases, and I'm going to go through this sort of quickly. I'll post the video, I'll post the summary notes, and so if you need to go back and listen to or look at this again, you can certainly do that. So the first case is when this angle is acute, right? And that's the one that we just sort of practiced. And so in that situation, the key is going to be figuring out this height. What's the shortest distance that reaches down here? And once we know that, then we're going to sort of do some comparing. That's not really a word, some comparing. And so to find that height, we just do SOHCAHTOA. So sine of angle A equals the height over B. And so of course that means then that the height equals sine of A times B. And so in that example that we did just a minute ago, we had a side of 5, and we had an angle of 30. And so this height, this shortest thing, would be height equals sine 30 times 5. And I'm sure we all remember sine of 30 is 1/2. So this height is 2.5. And so the first thing we realize is that there's a chance this isn't going to work at all. If side A is less than 2.5, it's not going to reach that bottom side at all. And so I've got a little diagram here where we can show this. And so I've got my angle A locked in at 30. I'm going to set side B at 5. And I can see here the height is 2.5. If A is 2, doesn't reach, right? There are no triangles that meet these criteria. And so we're just going to sort of stop right there and say, oh, okay, there aren't any triangles. I don't have to bother using the law of sines or cosines. It just flat out doesn't work. The other thing that can happen is if A gets longer than B, so maybe A is 7. Now when A is 7, I do know that if 5's long enough to reach, then 7's going to be long enough to reach also. And I have to drag this way out here. Let's see if I can zoom out a little bit. And so when I zoom out, I see that sure enough, that 7's going to reach. But there's no way it's going to reach twice. It's just going to reach once way over here. When is it going to reach twice? It's going to reach twice when that yellow side, that A, is right in this sweet spot, right between 2.5 and 7. And so this is what we had worked with. Let's try 3. Watch 3 now. 3 is going to hit once here. So there's a triangle that works perfectly well. And then it's going to hit once here, right? And so those are those two triangles that I had drawn. And we can see that this is going to keep working. Even if I make this like 4.8, right? It's going to keep working. It's going to hit once over there. It's going to be sort of a weird triangle. That bottom side is going to be super, super small, but it's going to hit over here again, and we're going to get two triangles. And so if we sort of summarize this, right? Sorry, let's get this pictured here. Right, so if the opposite side, side A, is less than the height, doesn't work at all. If the opposite side is bigger than the side next to it, side B, then we get one triangle. And we get two triangles right in that sweet spot there when A is between the height and the adjacent side. So in our example, when A is between 2.5 and 5, I get these two ambiguous triangles, right? I have to decide. I don't know which one it is, so I have to list both answers as possibilities. Why don't you pause the video here and do a quick think, pair, share. So think about this. Did it make sense? What parts didn't make sense? What questions do you have? Have a discussion in your groups, and then a quick discussion as a class to try and clear anything up as best we can, and then we'll do a little example. So pause the video. Okay, and welcome back. So let's actually see how we would do a calculation in this. So let's go back to the example we've been working with. So the height was 5 and this opposite side is 3. And so we already know there are two triangles. How would we actually go about finding them? And so we would set up a law of sines problem. So I know the sine of 30 over 3 has to equal the sine of b over 5, right? Because this is my angle b over here. And so I'm just going to cross multiply. So I get 5 sine of 30 over 3 equals sine of b. And we're switching over from chapter 5 now, right? Just like we said earlier. So we're going to make sure we're in degree mode. And so I'll do 5 times the sine of 30 divided by 3. So I get 0.833. And so now I'm going to do the inverse sine. And this is the part where I should always be wary, right? Because I know my calculator is going to give me an answer. And sure enough, it does. It says B is 56.4 degrees. And that's great. That has the correct sign. That's the correct answer. But I should always be worried. Remember, the calculator gives me one answer, but there are actually multiple answers. Now, adding 360 doesn't make any sense, right? Because we wouldn't fit in a triangle if I added 360. But remember, sine has another answer in the other quadrant. Normally in chapter 5, we said, oh, the other answer is pi minus the calc answer, right? But of course, now we're working in degree mode. And so instead of working in with pi, I'm going to say 180 degrees. And so I'm going to do 180 minus that 56.4. And I get 123.6. And so these are the two possibilities for angle B, 56.4 and 123.6. And those correspond to those two triangles that we had drawn earlier. And so if I go back here one more time and do 3, right? And so here, angle B is about 56.4. And here, angle B is 123.6, right? And in both cases, we could then find angle C and we could find side C, and we could completely solve the triangle if we wanted to. Why don't you pause here one more time before we wrap it up? Talk to a neighbor. How did this go? Was something too fast? Do you understand how we found that second angle B? Okay, welcome back. The last piece of the puzzle is when that angle is obtuse. So when angle A is obtuse, it ends up being much easier. There's no way you're ever going to get two triangles here, and deciding whether you get 1 or 0 is very easy. Basically, side A just needs to be long enough to reach to make a triangle, and the only way it's going to be long enough to reach is if A is bigger than B. So if A is bigger than B, it'll reach once here. If A is not bigger than B, then it doesn't reach at all, and it just stops somewhere, and you get 0 triangles. And so when A is obtuse, you never have to worry about the ambiguous case where there might be two triangles. It's either 0 or 1, and if you just sketch out a picture, it sort of makes sense. If A is obtuse, side A has to be the longest side, and if it's not, it doesn't work. Hopefully this came across okay in the video. Help each other, ask questions, work on the worksheet. The first few questions on the worksheet, you're just trying to figure out how many triangles are there, 0, 1, or 2. I really recommend drawing the picture so you can sort of get a handle on what's going on. And then after that, it's going to have you actually solve some and figure out the missing pieces. Have fun, and I'll see you tomorrow.